All right, folks, it's Mike. Back to, if you didn't see the first video on the rules for parallel circuit, if you understand that, that's fine. You don't have to watch that. But if you are not sure or you just don't get parallel circuits, how those numbers are coming out, please look at that first before we start here. Okay, it'll help you understand what's going on. But without further ado, I'm going to just do this one video here. This is on an example for the resistors are the same, okay? And we'll use rule C, which is where we're going to take our resistors that are the same. We're going to take one of those resistor numbers and we're going to divide it by the number of those resistors. Okay, so this is a parallel circuit that we can see. We have, remember what our first thing to do when we have our little matrix right here is write down the information that you have, that you know you do, so you can put it in an order that you can keep track of things and you don't get lost in it, okay? So the first thing we're going to do is we're going to put down 120 volts. That's what our circuit total is given. So in a parallel circuit, what stays and what changes? Do the volts change, or do the volts stay the same, or do the current stays the same, or the current changes? Okay, so in a parallel circuit, your voltage stays the same, so we can automatically bring down our 120 volts right off the get-go. We don't have to stress about those other things. It's given to you, okay, because you know the rules. The next thing is we're going to make sure we write down what our resistors that are given to us. So we have resistor 5 for resistor 1, or excuse me, 5 ohms resistance for resistor 1 and resistor 2. So we'll go ahead and put 5 ohms down here. Okay, so in order for us to figure this out, we're going to take 5 ohms. We're going to divide that by the total number that we have. We have 2. So 5 divided by 2 is 2.5. So our circuit resistance is going to be 2.5 ohms. Okay, and when you're doing these mathematical equations, when you first start getting into this, until unless you get into the engineering level, it's straight math. They're assuming that everything is what it is, because the reality of it is there's resistance in the wire and the terminations and all that stuff. And that's when they start getting into decimal points into oblivion. But for the basic, for you guys to learn what we're doing right now, everything is 100% efficient. So if it's 5 ohms, it's 5 ohms. Okay. But as you get farther along in this, if this is something that you want to pursue, there's more to it. Okay. But don't worry about that right now. So, do we have enough information at this point for us to figure out the rest of our circuit? Remember what I said? 2 pieces of information. We've got volts, we've got current, we've got resistance, and we've got power. So we have 2 pieces of information. We can figure out all the rest of it, right? So the next part is, we look up here Ohm's law. We want to find out current, so we cover our I up, and it's E divided by R. So 120 volts divided by 2.5 is going to give us 48 amps. Okay, just put an A there. So that's our circuit total. Now this is a very simple circuit for us to figure this thing out. All right, but this is a drill for you guys to get used to doing these numbers here. So now all of these have to add up to that number right there. Okay, again, very simple circuit for us. So we want to find out current again. We cover up our Ohm's law, and it's E divided by R. So 120 divided by 5. Well, what does that give us? It should give us 24. Okay. Now, you can look at this and go, well, I know it has to add this. I know without doing the math that this is going to be 24. I wouldn't get into that habit when you first start doing that stuff, because if you didn't do your math right on this one right here, and you might not catch it, and you're going to get that wrong when you get your paper graded or when you do your lab or whatever the case may be. Get used to doing your math every time, each individual. But because you know the rules, you can know, I did 24 and I did 24. These two have to add up to this. Do they? Yes. You've done your checks and balances and your quality control, quality assurance. Okay. So, do we have enough information to find our power? Yes, we do. Now we can do Watt's law here, okay, which is P over I and E. So if you can remember ear for this one, and pi for this one. You'll never forget it. Again, when you take a test, write those two things down on your scratch paper. As soon as they tell you go, don't do it beforehand. They accuse you of cheating. So for us to find our power, we got to do our current times our volts. Okay, so 120 volts times 2.5 gives us 5,760 watts. Okay, in watts, it's these, they have to add up. Okay, so 120 times 24 gives us 2,880 watts. And these are the same. This situation, it's the same thing. Now our 688 or 6,088 added, 2,088 times 2 equals, so these two here have to add up to that number right there. Okay. This is probably the simplest one that you're going to do. I'm going to do another video here, and we're going to start getting, I'll do a very basic one like this, 2 resistors, different resistor sizes, and we'll start confirming those laws that one of the rules that we've talked about here on that first video. Okay. And then we're going to get into the other one where we've got 3 or more, where we want to use a reciprocal method. Okay. Any questions? Please ask down below. I get that as soon as it comes in. It gets on my phone. I'd be more than happy to answer you. And if I can't explain it, I'll gladly put a video together so you guys can understand that. Okay. Again, stay safe out there.